In this video, we will talk about direct variation and how to solve problems involving direct variation. For the first part, I want you to pause the video and try to come up with the pattern for this table. Restart it once you've found it. If you look, for this pattern, every x value is being multiplied by 5. Negative 2 times 5 is negative 10. 0 times 5 is 0. 5 times 5 is 25. 12 times 5 is 60. And 20 times 5 is 100. If I wanted to write this as an equation, I would write y equals 5 times x. Looking at this next table, if you want to pause the video to try to find it yourself, you will easily see that this time you are multiplying by a negative. The pattern for this table is that we are multiplying by negative 2. Each x value multiplied by negative 2 gives us our y value. So our equation here would be y equals negative 2 times x. Now, looking at our next one, you will find that it looks like it's going to be multiplying by 2. Negative 4 times 2 is negative 8. However, 5 times 2 does not equal 15, so it doesn't work there. 7 times 4 gives us 28, and 12 times negative 2 gives us negative 24. Since these are not the same pattern, we're going to just write none. This would not be considered direct variation. In order for it to be direct variation, it has to follow the same pattern throughout the entire table. So you don't want to just check the first line, you need to make sure you check all of them. This one might be a little bit more challenging to find. Go ahead and pause the video and try to find the pattern. If you look at this table, on this time you are actually dividing by a number. Negative 12 divided by 4 is negative 3. 4 divided by 4 is 1. 8 divided by 4 is 2. This is the same thing as multiplying by 1/4. And it follows the pattern all the way through. 16 times 1/4 is 4. 24 times 1/4 is 6. You can write this two different ways. You can write this as 1/4 x, or you can write this as x over 4, x divided by 4. Those mean the same thing. For our last table, go ahead and try to find the pattern on your own and then restart the video. This one might have been a little bit more challenging to find. If you look on this one, you are actually multiplying by 2/3. If you can't find it on your own, one way you can try to find it is by doing y divided by x. 4 over 6 is 2/3. 2 over 3 is 2/3. 2/3 divided by 1 is 2/3. So you are multiplying each x value by 2 over 3. So when it's a more complicated fraction or decimal, you can always find it by dividing y over x. This is the whole meaning of direct variation. Direct variation follows the pattern y equals kx. K is like your slope, like the m value that we've talked about before. K is also known as your constant of variation. With direct variation, your y-intercept will always be 0. I could add a 0 here and it would mean the same thing. So with direct variation, you're not adding or subtracting anything to x. You are only multiplying a number by x. Let's look at our next example. It says, suppose y varies directly with x, and y equals 14 when x is 2. Find x when y equals 35. Then state the constant of variation. I am going to show you two different methods to solve this. The first one is by using our equation. When it says y varies directly with x, that means y equals k times x. There's our formula. Then it says when y is 14, x is 2. I can plug in that information and solve for my constant, solve for k. The opposite of multiplying by 2 is to divide by 2. So I just found that my constant of variation is k. That answers the second part of the problem. But I still have one more thing that I need to find. I need to find x when y is 35. So now that I know that my equation is y equals 7 times x, I just plugged in the k, I am going to plug in 35 for y, and I am going to solve for x. If I divide both sides by 7, x equals 5. I have two answers to this problem. The first one goes with the sentence that says find x when y is 35. The second one goes with state the constant of variation. So let's assume you already know the constant of variation. Since this is direct variation, you can actually set this up as a proportion. So if I set this up with x over y, then when x is 2, y is 14, and then I'm trying to find x when y is 35. You did this back in middle school. So you can cross multiply. 2 times 35 is 70. 14 times x is 14x. And then when you divide, you get the same answer. X is 5. You can use either method when solving for x. Go ahead and pause the video, try this problem on your own, and then restart when you're ready to check. For the first method, using our equation, y varies directly with x. Y is 42 when x is 7. So when I'm solving for k, I divide both sides by 7, and my constant is 6. This means that my equation is y equals 6 times x. I just plugged in the k. Then it says find x when y is 72. If I plug in 72 here, then to solve for x, I'm going to divide both sides by 6, meaning x is 12. I have my two answers. If you prefer to set up a proportion, then if I have x over y, 7 over 42 equals x over 72. Well, 7 times 72, if you have to do this without a calculator, is 504. And 504 is going to be divided by 42. And when you do that, we get 84, which gives us 12. Either way, you're going to get the same answer for x. All right, this example says volume varies directly with height. This really doesn't change anything except for the variables we're going to use. So if the volume varies directly with the height, then V is K times H. Volume varies directly, so we're using V equals. If the volume is 600, when the height is 20, then I first need to find my constant. To find this, I'm going to divide both sides by 20, and we get 30. This problem is only asking for the equation relating V to H. So now that I have my K value, that's not my final answer. My final answer needs to be the equation. V equals 30H. Go ahead and pause the video, try this one on your own, and restart when you're ready to check. On this problem, the weight varies directly with the height. So W is K times H. If the weight is 1400, when the height is 70, I need to figure out what my constant is. To do this, I'm just going to divide both sides by 70, and my constant is 20. I'm not finished though. It wants an equation relating W to H. So my final answer is W equals 20H. Our last problem looks very similar to the one we just did, but instead the last problem said weight varies directly with height. This one says height varies directly with weight. So this time, instead of W equals, we are going to use H equals. This does make a difference in your equation, so you have to read carefully. If the weight is 1400, when the height is 70, here's how this changes things a little bit. If I am solving for K, then I'm going to divide both sides by 1400. When I do this, this simplifies to 1 over 20 instead of 20. So by switching the variables, instead of before having W equals 20H, now I have H equals 1 over 20 W. So you have to pay attention to which variable comes first. That's it for our direct variation notes. Just remember y equals kx, and k is your constant of variation.